Okay, so we're on cubic equations with complex roots. Now, for those who don't remember what cubic equation is, a cubic equation is something like this, like basically you get like z cubed plus 3z squared plus, I don't know, 10z plus 25, something random like this is a cubic equation. Z to the power 3 makes it a cubic equation. Now, cubic equations, we might have factorized them in the past into just like a simple number, something like this. Okay, and these are the factors that they'll divide into this. Okay, and that's usually what happens. But in this one, we can also get when all the polynomials. Okay, so for example, so when all the coefficients, excuse me, so 3, 3, 10, and 2, when all those are real, what happens is you're going to end up with one real coefficient, and then you're going to one real factor or a real root, and then you're going to end up with like basically complex number ones to go with it. So that's what happens there, and usually the complex number ones are the conjugate of each other, so minus I plus 3 are the conjugate. Okay, so that's what we're doing. So that's the conjugate root theorem. If all the coefficients of a polynomial equation are real, then all the complex roots occur as conjugate pairs. Okay, so moving on. Okay, what we have here is question 2. Okay, it gives us a polynomial, and then it goes verify that p of 3 equals 0. So to verify that p3 equals 0, we replace all z's with 3's, because pz is going to be 3 cubed plus 3 squared plus 3 minus 39. So we're going to get 27 plus 9 plus 3 minus 39. It's going to be 39 minus 39 equals 0. Okay, so that's basically what happened there. Okay, so it's 39 minus 39 equals 0. Now, this means that z equals 3 is a root. Now, if that's a root, then what we have to figure out is, if that's a root, then what's a factor? So we used a factor theorem, where this means z minus 3 will divide into this here. So what we're going to do is we're going to do long division into z cubed plus z squared plus z minus 39. Okay, and then we're going to multiply it in, and we're going to get z squared, and we're going to get z cubed minus 3z squared. Then we're going to take it away, and then we're going to get 4z squared plus I think that's 1z. So plus 1z goes down. Then divide that in again, it goes 4z times this time. So 4z multiplied by z is 4z squared. 4z multiplied by 3 is minus 12z. And then once again, you got to take them away and change the signs. Okay, and then we're going to get 13z minus 39. And then this time it should go in plus 13 times, because 13z divided by z is 13. And then we're going to have 13z minus 39. Take them away, and you change the sign, and you get 0. We now know that this z squared minus 4z plus 13 is the other factor. So basically what we've exchanged this with is basically we divided in, so this polynomial, or this cubic equation, it can be made by multiplying z minus 3 multiplied by these two here. These two multiplied by each other give you this equation back. Now what we have to do is we have to figure out what is the roots. The roots is when it equals 0. Okay, so all this has to equal 0. We know when z minus 3 equals 0, z equals 3. We already knew that that was a root. This leaves this part remaining, and as we can see, it's a quadratic equation. So a is going to equal 1, b is going to equal 4, and c is going to equal 13. Okay, so 1, 4 and 13. So minus b formula. So minus b is going to be minus 4. So we're going to get a minus 4 plus or minus the square root of b squared, which is going to be 16, minus 4ac minus 4 times 1 times 13, minus 52 to my knowledge, all over 2 times 1. That's going to be minus 4 plus or minus the square root of minus 36 over 2, which we all know is 6i at this stage, all over 2. And then we're going to get minus 2 plus 3i and minus 2 minus 3i, and there's your two conjugate roots there. There's your two roots. Z equals this one and Z equals that one there. Okay, so in this question 3 we're doing find the cubic function f of x where it's equal to x cubed plus 7x squared plus 17x plus 15 has one integer root and two complex roots. Well, to find the integer root, what we can say is the following. We can basically say that the integer root has to be something related to 15. So I'm thinking numbers like 15 itself, minus 15, 3, minus 3, 5, minus 5. Now before I'd actually 1 even and minus 1. Beforehand I would actually have to test this out. Test out all these numbers. Okay, so what I'm going to do this time around is I'm going to use the calculator function to find out what's what before I begin. So I'm going to go into the table function and then I'm going to put in these values here. X cubed, yeah, plus 7x squared, plus 7x squared and then plus 17x and then plus 15. Okay, and that's done to start, right? So I'm going to start from, let's say, minus 1 up to plus 15, okay? And let's hope I hit lucky. Step of 1. And look at this, I'm looking for when the f of x value equals 0, because that proves that it's a root. It's a root when the f of x value equals 0. So I'm going to scroll down and hope that I hit lucky, and as I can see it's not happening. Okay, so now I'm going to retry this again, except this time from minus 1 back to 15. Okay, so we go back to where we were. Okay, so we're going to try this again. X cubed plus 7x squared, 7x squared plus 17x and then plus 15. And then I'm going to go from minus 15 has to be the start, because the start has to be before the end. The end, let's call it 1, step of 1. Let's keep looking again. And we can see we nearly have it. It's coming down to the 0 mark. We can nearly have it there. Minus 5, minus 3. Minus 3 is the root. Okay. Now because x equals minus 3 is the root, we also have to prove it is the root. So what we have to do is we have to write down f of minus 3. And f of minus 3 is minus 3 cubed plus 7 times minus 3 squared plus 17 times minus 3 plus 15. And we get there is minus 27 plus 63 minus 51 plus 15. Okay, and we're going to get minus 78 plus 78 equals 0. Okay, so now that we know that z minus 3, or sorry, x equals minus 3 is a factor, now we know that, bring the 3 over to your side, we know that x minus 3 is a root, therefore x plus 3 is a factor. Okay, and we can divide this x plus 3 straight in here. Okay, x cubed plus 7x squared plus 17x plus 15. We can divide this in. We're going to get x squared, so that's going to be x cubed plus 3x squared. Take them away, and we're going to get minus 10x squared. Bring down the 17x. X into minus 10x squared goes minus 10x times. Then we're going to get minus 10x squared minus 30x. I think minus 10x anyway. Oh, sorry. So I think I just made a brief mistake on that last part. I think it was 7x squared minus, so it was minus 3x squared, which is 4x squared, so just going too fast. Then we have to change that in turn, so it's actually going to be plus 4x. 4x times that is 4x squared, and 4x times 3 is 12x. Okay, and that's 17x. So we're saying 4x squared, okay, into both of them, and then we're going to take it away. Now we get 5x plus 15, and lo and behold, there's your plus 5 at the end, because x divided by 5x divided by x is plus 5, so it's going to be 5x plus 15, and then you just take them away from each other and you get 0. Okay, so there is our other factor there. Okay, now once we have this other factor, what we got to do then is we actually got to go about solving it. And to go about solving it, what we need to do is this. We do the minus b formula, we put it equal to 0, and we say let a equal 1, b equal 4, minus b equal to minus 4, then c equals 5. Do the minus b formula, minus 4 plus or minus square root of b squared, which is 16, minus 4ac. 4 times 1 times 5 is minus 20, all over 2. Then we have minus 4 plus or minus the square root of minus 4, all over 2. Minus 4, as we all know, is 2i, so it's minus 4 plus or minus 2i all over 2, which is going to be minus 4 plus I and minus 4 minus I. Now that brings us on to the next part of this question, okay, so it's, we'll just bring these answers up here. So what brings us on is the next part. Using part 1 or otherwise, solve this equation here. X minus 2 cubed, 7 minus x minus 2 squared, 17x and 15. The key thing here is to look at the coefficients of each one. Okay, so the coefficients being 1 here, 7, 17 and 15, and we can see it's the exact same thing, 1, 7, 17 and 15. So so these are the x answers, or the old answers, okay, and this x value has now been replaced with x minus 2. Okay, so instead of x, it's now x minus 2. Sorry guys, just after making another brief one there, I just had to divide by 2, so it's actually minus 2 plus or minus I for that part there, minus 2 plus or minus I. Okay, because I forgot to divide the 4 by the 2 as well. Okay, so it's minus 2 plus or minus I. I'm going to bring that up top here, and then we're going to solve the rest of it there. Okay, so hence or otherwise solve this equation. So we set that z equals 3, or sorry, x equals 3, x equals minus 3, x equals minus 2 plus 1i, and then x equals minus 2 minus 1i. So basically there are answers there, okay? Okay, so in this one here, okay, this is exactly the same equation, except it has a new variable x minus 2, because it has the same coefficients as the one above. So basically what we're now going to have is that x minus 2 equals 3. We have x minus 2 equals minus 2 plus I, and then we're going to have x minus 2 equals minus 2 minus I. So what happens is, bring the minus 2 over, and we get that was minus 3, excuse me. So x equals minus 3, so bring the minus 2 over, comes a plus 2, then we have the answer x equals minus 1. The next one we're going to have is that x equals, the minus 2's cancel and x equals I. And then the last answer is going to be the minus 2's cancel and x equals minus I.